Hello, today we're going to look at practice C and go through the answers. So again, we're looking at organizing and describing data specifically with bar graphs, line graphs, and circle graphs. So let's look at the double bar graph. So over here, we have the days of the week and then how many people visited a library. Okay, so let's take a look. About how many times more females than males attended the library on Wednesday? So what we need to do is identify, well, how many females and how many males attended the library. So Wednesday, if I take a look, these are going from 60 to 80. So let's see, they're going up by 20s. Oh, let's see here, 60. Let me see, 1, 2, 3, 4, 5. We got 70 somewhere in the middle. Well, let's just say that's about 79. And then how many males? All right, that's right on that line, which happens to be 20. So the question says about how many times more females than males. So females to males, I'm going to do 79. And I'm going to divide it by 20. When I do 79 divided by 20, I get about 3.95 or about 4 times. Okay, since it says about, we can take it up to about 4 times the number of 4 times the number of males that were at the library were females. All right, number 2 says, on which day of the week was library attendance by males and females the closest? So let's visually look at our bar graph. Where are the females, where's the light gray and the dark gray the closest together? Well, definitely not Monday or Tuesday, definitely not Wednesday, Thursday. Look at Friday. Friday and Saturday we have the closest. Again, we visually look here. Friday, the number of females and males were definitely the closest. So our answer is going to be Friday. Number 3, on which day did the library have the least number of patrons? So it doesn't matter male or female. This is where we need to go and identify, well, how many males and how many females showed up on a given day. So if I look here, this right here is about 60. Let me think about this. Oh, 570, 580. Of course, it's going by different numbers. Oh, let's call this 68. And let's call this one 20. We're looking at about 28 here, because again, halfway would be about 30. All right, so 68 and 28, 68 plus 28, we had 96 people show up on Monday. Let's look here. We have about 56 here, and Tuesday, we're looking around somewhere right around 30. So 56 plus 30 would be 86. Okay, we already said these two numbers would be 79 and 20, when that gives us about 99. How about Thursday? Okay. Oh, let's see. Well, this is right on 20, so that one's easy. And then this one is going to be right above 40. Let's call it 41. So we're looking at 61. So right now, that's the least number. Friday, we have, that's 40, let's say 38, and again, these are very close, so we'll say 38 and 37, which would give us about 75, and then definitely Saturday, we're going to say is not close at all. 80, let's say that's 83, and we'll say that is about 92. So 83 plus 92 is 175. So the day that the library had the least number of people show up was definitely Thursday. Now let's look at the double line graph. And here we have the cost of two different products. We have product A, product B, and years on the market. And we can see what is happening to the cost of product A and product B. If we look at product A over time, it starts off pretty expensive, price definitely falls, and then steadies out for the most part. Product B starts out pretty cheap and has a steady increase, okay? So that's like the overview of what the line graph really is. So let's answer these questions. How many years had the product been on the market before their costs were about the same? Well, same means, well, they're about equal. Let's look. How many years? It had been on the market for about 3.5 years before those costs were the same. So let's call it about 3 to 3.5 years. All right, let's look at number 5. How much more was the difference in cost during year 1 than year 8? So how much more was the difference? Well, the difference means I'm going to have to subtract. So I need to find the difference between the two product costs in year 1 and also in year 8, and then subtract those. So if I look at year 1, product A is about $225. Product B is about $158. So $225 minus $158. So it's about $67 difference between year 1 and product A and product B in year 1. Then I'm going to go do the same thing for year 8. So right here, if I take this over, we're looking right under $10 for product B. And product A isn't quite at 170, right? 170 would be just above it. So let's call it 168. So 210 minus 168 is $42. So what is the difference in cost during year 1 than year 8? Well, in year 1, the difference was $67. In year 8, it was $42. So 67 minus 42 is about $25. 67 minus 42 is about $25. If you have something close to that, that would be good. As long as you're doing the same math, you're finding the cost in year 1 of both products, in year 8, finding the difference between those, and then taking the difference, like I said, between year 1 and year 8. So $25, $30, depending on where you estimated. Number 6 says, describe the trend of the cost of product A over the 8 years shown. Well, A decreases pretty quickly. The cost decreases quickly and then steadies out. So the cost decreases quickly, then remains pretty steady. And it looks like product B just steadily increases and definitely has a bigger jump between year 6 and year 7. And the last thing is the table shows the number of customers who ordered each of the different types of burgers at Luke's Place on a given day. Use the data to make a graph. Explain why you chose the type of graph. So once again, I'm looking here and we're going to compare each type of burger that was bought to the total amount sold. So if I'm going to compare that, I want to make a circle graph. And so what I can do is I can turn all of these into percentages because that's how my mind works in terms of marking off different pieces of the circle graph that is a good sketch and good representation of percentage data. So I have to find out what percentage each of these are. Well, that means I need to find the total. So if I add 24 plus 16 plus 12 plus 8 plus 2, I know that Luke's Place had a total of 62 burgers sold, right? Or 62 customers. So now I'm going to do each of these divided by 62 and get their percentages. And if you do that, you should get the following percentages. 38.7% for cheese. Fiesta's 25.8%. Blue, I'll write it down here, is 19.4%. Mushroom would be 12.9%. And veggie would be 3.2%. So not many people like veggie burgers, I guess. So if I take a look, I'm going to look for any of those pieces or that are like a quarter of the circle graph or half of the circle graph. So I'm going to start off with my Fiesta burger and make it about a fourth. Okay, so that's Fiesta. And that's about 25.8%. All right, so then my next group, I'm going to take a look. Well, what makes sense in terms of quarters or halves? So when I look at, let's see, 38 and 19 and 12 would give me about 69, which is just under 75. So that means that the rest of this would be 75. But I'm going to cut it off here because this is going to be my veggie at 3.2, since I combined 38.7, 19.4%, and 12.9% to get about 75%. Okay? Well, if this is 25% and I need 38, I'm going to use this dotted line as about 25. Like I said, this is going to be my cheese. And again, these are rough estimates. Trying to draw a circle graph, when you sketch one, you try to make it as accurate as possible in terms of visually representing the data. So cheese is 38.7%. And then I have blue and mushroom, and blue being a tad bit more than my mushroom. So here's your blue cheeseburger at 19.4% and your mushroom at 12.9%. You could have represented this data using a bar chart, and that would have been fine as well, but I do like to compare visually using a pie chart of what the different customers order. So then when the manager of Luke's Place is ready to place an order for more food, he or she can see, well, wait a second, cheese was still by far the most popular, and the veggie burger maybe not so much. So maybe they'll use this data to more accurately order food the next time they need to. All right, thanks for watching. Make any corrections before you turn it in. Have a great day.